Now question number 61 is, given are two matrices A and B, and it says we need to find whether or not there exists a matrix C such that A equals BC is equal to CB. Now we'll take this equation which is A equals BC. Now what is the determinant of B? Determinant of B is 1. So that means B inverse exists. So we can write B inverse into A, it is equal to C. So it is possible to have a matrix C which is equal to B inverse A such that A is equal to B into C. So what we'll do is we'll find B inverse. B inverse will be simply 1 0 0 minus 1 1 0 and 0 minus 1 and 1. So it is possible to have a matrix C such that A equals BC. Now once we have B inverse, we can find C. We can write C as 1 0 0 minus 1 1 0 0 minus 1 1, and then we'll multiply it with A, which is 1 1 1 1 2 2 and 1 2 3. So we'll multiply it, we'll get 1 1 and 1. Here it will be 0 1 and 1, and this one will be 0 0 and 1. So that is the value of C. Now we need to check if we'll multiply C with B, whether or not we'll get this A. So we'll multiply CB. C into B will be 1 1 1 0 1 1 0 0 1, and then value of B is 1 0 0 1 1 0 and 1 1 and 1. Now we'll multiply it, we'll get this as 3, and which is clearly not equal to A. So CB is not equal to A. So we'll have a matrix C such that A equals BC, but A cannot be equal to CB, and that's your option number C. Now question number 62 is, if this matrix has 1 as its eigenvalue, then we need to find trace of A. So we know that its characteristic equation will be A minus X 1 2 and 3 minus X, it is equal to 0, and one of the solution of this equation is 1. So we'll get A minus 1 1 2 and 2, it must be equal to 0. So we'll get 2A minus 2 minus 2 equals 0. So value of A is simply 2. So if the value of A is 2, we need to find trace of A. So trace of A, it will be nothing but A plus 3, which is 5, and that's your option number B. Now question number 63 is, we are given this matrix A, we need to find A to the power 2010. Now we'll find A square, we'll get cos theta sin theta minus sin theta cos theta into cos theta sin theta minus sin theta into cos theta. Now we'll multiply it, we'll get cos square theta minus sin square theta. So it will be cos 2 theta. Now here it will be 2 sin theta cos theta, and that should be sin 2 theta. This one is minus sin 2 theta, and this is cos 2 theta. So from here we can say A to the power n should be cos n theta sin n theta minus sin n theta and cos n theta. We can prove this result using induction also. Now we need to find value of A 2010. So value of A to the power 2010 will be cos 2010 theta sin 2010 theta and minus sin 2010 theta and cos 2010 theta. Now value of theta is 2 pi by 67. So we'll find 2010 into 2 pi by 67. It will be 30, and it should be 60 pi. Now this is cos 60 pi. It's a multiple of 2 pi. Cos 2 pi is 1, sin 2 pi is 0. So it is nothing but 1001, and that's your option number B. Now question number 64 is, let the position of particle in 3 dimension at time t be given by t cos t sin t. Then we need to find length of the path traversed by particle between 0 to 2 pi. So we know that L is given by this integral from 0 to 2 pi and then under root of dx square plus dy square plus dz square. Now x is t, so dx is dt, dy is minus sin t dt, and dz is cos t dt. So we can write this length as from 0 to 2 pi this integral, and then here we'll get this as 1 plus sin square t plus cos square t into dt. Now sin square theta plus cos square theta, it is 1, so it will be root 2, and then this integral from 0 to 2 pi dt, which is nothing but 2 pi. So it will be 2 root 2 into pi, and that's your option number B. Now question number 65 is, if n is positive real number and p is a positive integer, then which of the following inequalities is true? So what we'll do is, we'll compare this expression, which is n plus 1 to the power p plus 1 minus n to the power p plus 1. Now what we'll do is, we'll take n to the power p plus 1 common. We can write 1 plus 1 upon n to the power p plus 1 minus 1. Now if we'll use binomial expansion, then we can write n p plus 1, and this is 1 plus p plus 1 n, and then p plus 1 into p upon factorial to 1 upon n square minus 1. Now this value, it will always be greater than or equal to n to the power p plus 1 into p plus 1 upon n. So from here we can say n plus 1 to the power p plus 1 minus n to the power p plus 1 is greater than or equal to n to the power p into p plus 1, and which is your option number B. We can use strict inequality in this case because we have left many terms. So n to the power p, it should be less than, we'll take this p plus 1 on the right hand side, we can write n plus 1 to the power p plus 1 minus n to the power p plus 1 upon p plus 1. Now question number 66 is the smallest positive value of k for which this inequality holds. We can write this inequality as mod of sin square x minus sin square y upon x minus y, it is less than or equal to k. Now we look at this expression, which is sin square x minus sin square y upon x minus y. If we'll take this limit y tends to x, then we know that it is nothing but fx minus fy upon x minus y, and which is nothing but derivative of sin square x. So it'll be 2 sin x cos x, and it is less than or equal to k. So we can write sin 2x is less than or equal to k. Now we know that maximum value of sin 2 theta is 1. So that means this expression is always less than or equal to 1. So the smallest positive value of k is 1, and that's your option number B. Now question number 67 is, we are given this expression dxab as minimum of x minus y when y lies between a and b. So basically this is minimum distance of any point x from this interval a and b. Now it depends whether this x, it lies between ab or on the left of a or on the right of b. So when we have this dx 0, 1, we know that dx 0, 1 will be 0. If x lies between 0 and 1, it will be mod x when x is less than 0. So when x is less than 0, then minimum distance is x minus 0. So we have taken this as mod x. And when x is greater than 1, then minimum distance is mod of x minus 1. In the same way, we can define dx23. Now this dx, this interval 2, 3, it will be 0. When x lies between 2 and 3, it will be mod of x minus 2 when x is less than 2, and it will be mod of x minus 3 when x is greater than 3. Now we'll take this first case when x lies between 2 and 3. So when x lies between 2 and 3, dx01 will be mod x minus 1. We can write this function fx as mod x minus 1. Now again here it will be mod x minus 1 and then plus 0. So this value is 1. So when x lies between 2 and 3, fx is 1. Now what about this interval when x lies between 0 and 1? When x lies between 0 and 1, then we can write fx as 0 upon 0 plus, and this x will be mod of x minus 2. So in that case, it will be 0. So answer to this question is option number D. Now question number 68 is, we are given this function in two variables fxy as e to the power minus 1 upon x square plus y square. When xy, it is not 0, 0, and it is 0 when xy approaches origin. Now first we'll check whether this function is continuous at 0, 0. So now if we'll take this limit, which is limit x, y, it approaches 0, 0. We can write this as e to the power minus 1 upon x square plus y square. So it will be e to the power minus infinite, which is 0. Now f 0, 0 is also 0. So we can say that this limiting value is equal to f 0, 0. So that means this function is continuous at 0, 0. Now we look at its first order partial derivatives. Now we can write fx 0, 0 as limit h tends to 0 f h, 0 minus f 0, 0 upon h. So it will be this limit h tends to 0. Now what is f h, 0? It will be e to the power minus 1 upon h square minus 0 upon h. Now this limiting value is also 0. And in the same way we can show that f y 0, 0 is also 0. So that means this function, it does have first order partial derivatives. Now we need to check whether this function is differentiable or not differentiable. So from definition we can say that this function will be differentiable when this limit h, k tends to 0, 0 and it will be e to the power minus 1 upon h square plus k square, because partial derivatives, they are all 0 and function value is also 0, upon under root of h square plus k square, which is same as e to the power minus t upon under root t when t tends to 0. And this limit again, it tends to 0. So that means this function is differentiable at 0, 0, and that's your option number D. Now question number 69 is, consider this function from 0 to x 5 plus 1 minus y dy when x is greater than 2, and then 5x plus 2 when x is less than or equal to 2. Now we need to find whether this function is continuous and differentiable at 1 and 2. Now we know that its definition changes at 2. Now we'll find f2 negative. F2 negative will be 5 into 2 negative plus 2, that is nothing but 12. Now we'll find f2 positive. F2 positive will be this integral from 0 to 2, 5, and then mod of 1 minus y dy. Now this is 5 integral from 0 to 2 dy, and then plus 0 to 2 integral of 1 minus y dy. Now this is 5 into 2 and then plus from 0 to 1 minus y dy, and then from 1 to 2 y minus 1 dy. So it is 10, and then here it will be y minus y square upon 2 from 0 to 1 and plus y square upon 2 minus y from 1 to 2. So this is 10. Now here it will be 1 minus 1 by 2, and here it is 1 plus 1 by 2, and it will be 4 minus 1, and then minus 2 minus 1 is 1. So here 1 and 1 will cancel. So we'll get this as 10 minus 1 by 2 plus 3 by 2, which is 11. So left hand limit is 12 and right hand limit is 11. So this function is not continuous at x equals 2. Now question number 70 is, let w equals log u square plus v square, we need to find partial derivative of w with respect to x. So del w upon del x will be 1 upon u square plus v square 2u del u upon del x plus 2v del v upon del x. Now u is e to the power x square plus y. So del u upon del x will be e to the power x square plus y into 2x, and del v upon del x, it will be e to the power x plus y square into 1. Now we'll put the value of x and y as 0 and 0. So we'll put x and y as 0. We'll get u as e to the power 0, which is 1. We'll also get v as e to the power 0, which is 1. So we'll get this as 1 upon 1 plus 1, and it'll be 2. This is 1. Now what is del u upon del x? Del u upon del x is 0 when we put x as 0, and plus, now 2 times, what is the value of v? Value of v is 1. And what is del v upon del x? Del v upon del x is 1. So it'll be simply 2 upon 2, and which is 1. And that's your option number B. Now question number 71 is, again we are given a function in 2 variables and we have to find its continuity and its partial derivative with respect to x. Now we'll find this limit xy tends to 0, 0. So it'll be this xy. Now we'll put xy is 0, this is 0. So this limiting value is 0, which is not equal to f 0, 0, which is given as 1. So this function is not continuous at 0, 0. Now we'll find fx at 0, 0 will be this limit h tends to 0 f h, 0 minus f0 upon h. So it will be simply this limit h tends to 0, f h0 will be 0 minus f0 is 1 upon h, and this value, it tends to minus infinite. So that means this function is not continuous and partial derivative does not exist. That's your option number D. Now question number 72 is, we are given this function fx and it is given that this function is differentiable at x equal to 0. We need to find this condition. We can write this function fx as a0 cos x minus a1 sin x minus a2 x cube when x is less than 0, and it will be a0 cos x plus a1 sin x plus a2 x cube when x is greater than or equal to 0. f0 negative, it will be a0 and this is 0, so it will be a0, and f0 positive will also be a0 and the value at 0 is also a0. So this function is continuous at x equals 0. Now we'll differentiate this function. We can write this as minus a0 sin x minus a1 cos x minus 3a2 x square when x is less than 0, and it'll be a0 minus sin x plus a1 cos x plus 3a2 x square when x is greater than 0. Now we'll find f dash 0 negative. F dash 0 negative will be, this is 0, this is 0, so it'll be simply minus a1, and f dash 0 positive will be plus a1. Now since this function is differentiable, so minus a1 must be equal to a1. So from here we'll get the value of a1 should be 0. So answer to this question is, this map will be differentiable if the value of a1 is 0. Now question number 73 is, if a function fx is a differentiable function such that limit x tends to infinite fx is 1 and limit x tends to infinite f dash x is alpha, we need to find the value of alpha. Now what we'll do is, we can write f n plus 1 minus fn as fn plus 1 minus fn upon n plus 1 minus n. Now this is nothing. It is slope of this function at some point. This is equal to some f dash c where c belongs to n comma n plus 1 using Lagrange's mean value theorem. Now we'll take this limit n tends to infinite f n plus 1 minus fn, it will be this limit n tends to infinite f dash c. Now when n tends to infinite, this limit, it is equal to 1. So it is 1 minus 1, and then this limit, which is limit n tends to infinite f dash c. Now when n tends to infinite, this c also tends to infinite. So basically this n tends to infinite f dash c is nothing but alpha. So this is alpha. So from here we can say value of alpha, it must be 0, and that's your option number A. Now question number 74 is, we are given two functions such that f dash x minus g dash x is less than equal to 0 when x is less than 1, and f dash x minus g dash x is greater than equal to 0 when x is greater than 1. Now we need to find relationship between fx and gx. So we'll consider this function hx, which is fx minus gx. Then we can write h dash x as f dash x minus g dash x. Now we'll consider this first case when x is less than 1, that is when f dash x minus g dash x is less than equal to 0. So here we can say this h dash x is less than equal to 0, implying that hx is a decreasing function. Now if hx is decreasing and if x is less than 1, then hx is greater than h1. Now what is hx? Hx is fx minus gx, and it will be greater than f1 minus g1. If f1 is greater than g1, then f1 minus g1 is greater than equal to 0. So from here we can say fx must be greater than or equal to gx. So when x is less than 1, fx must be greater than equal to gx if f1 is greater than g1. Now we'll take the second case when x is greater than 1. Now when x is greater than 1, h dash x, which is f dash minus g dash, it will be greater than 0. In that case, hx will be an increasing function. So when hx is increasing, if x is greater than 1, then hx is greater than h1. Now hx is fx minus gx, and it is greater than f1 minus g1. Now f1 is greater than g1, so it is greater than equal to 0. So we can write fx is always greater than equal to gx. So for both the cases, we are getting this result, which is fx is greater than or equal to gx, and that's your option number A. Now question number 75 is, we need to find length of this curve. Now we know that this L is integral of under root of dx square plus dy square. Now dx is 3t square dt and dy is 6t dt. So we can write this L as this integral from 0 to 4 under root of, now it will be 9t to the power 4 plus 36t square into dt. Now we'll take 9t square common, so we'll get 0 to 4, and then it'll be 3t under root of t square plus 4 into dt. Now we'll take t square plus 4 as some z. So let t square plus 4 as some z square. Then we can write t dt as z dz. We can write this as L, and L be equal to 3 z into z dz. Now what are the limits? So when t is 0, z is 2, and when t is 4, it will be 16 plus 4, 20, and 20 is 2 root 5. So we'll get this as 3 z cube upon 3 from 2 to 2 root 5. So it will be 8, and then 5 root 5 minus 8. So it will be simply 8, 5 root 5 minus 1, and that's your option number D. Now it is given that this integral from minus infinite to plus infinite e to the power minus x squared dx is equal to under root pi, which is nothing but a Gaussian integral, which we have discussed in one of the previous videos. I'll provide the link to that video in the description below. Now, using this, we need to find this integral, which is from minus infinite to plus infinite e to the power minus x square plus xy plus y square dx into dy. So what we'll do is, we'll write this integral as from minus infinite to plus infinite, and then from minus infinite to plus infinite e to the power minus, and then x plus y by 2 whole square plus 3 y square by 4 into dx dy. Now what we'll do is, we'll let this x plus y by 2 as sum u. Then we can write this integral as from minus infinite to plus infinite, from minus infinite to plus infinite e to the power minus u square plus 3 y square upon 4, and it'll be simply du into dy. Now we'll separate this integral. We can write from minus infinite to plus infinite e to the power minus u square du into this integral from minus infinite to plus infinite e to the power minus 3y square upon 4 dy. Now this is nothing but under root pi. So we can write this as under root pi, and then this integral, which is from minus infinite to plus infinite e to the power minus 3 y square upon 4 dy. Now what we'll do is, we'll replace root 3 by 2y with some variable t. So we can write this as dy equals 2 upon root 3 dt. So this integral will now be under root pi, and then from minus infinite to plus infinite 2 upon root 3 e to the power minus t square dt. Now again, integral of e to the power minus t square is under root pi. So it will be 2 pi by root 3, and that's your option number D. Now question number 77 is, let R be a triangle in the xy plane bounded by the x-axis and y equals x line. So we have this y equals x line, and then we need to find, and R is this region which is bounded by x equals 0, x equal to 1, and this given line. Now we need to find value of this double integral in this region R. Sin x upon x dx into dy. Now one of the way of solving this question can be, we can write this integral as from 0 to 1, and then from 0 to, now y is x, so it will be from 0 to x sin x upon x dx into dy. So we can write this as from 0 to 1, and now here will be sin x upon x into dx, and this integral dy from 0 to x, it is nothing but x. So we can write this as from 0 to 1 sin x upon x into x dx. Now here x and x will cancel. Now integral of sin x is minus cos x from 0 to 1. So it will be 1 minus cos 1. So value of this double integral will be 1 minus cos 1, and that's your option number A. Now here we need to find the value of this limit, which is limit n tends to infinite n plus 1, this integral from 0 to 1 x to the power n log 1 plus x into dx. Now we'll take this log as first function and this x to the power n as second function. We can write this limit as limit n tends to infinite. Now it will be n plus 1, and here we'll use by parts. So first function as it is, and then it will be x to the power n plus 1 upon n plus 1 minus, now derivative first, so it is 1 upon 1 plus x, and then it will be x to the power n plus 1 upon n plus 1 into dx. Now we'll put the limits. Limits are from 0 to 1. Now here n plus 1 will cancel. So we can write this as limit n tends to infinite. Now we'll put x as 1, it'll be log 2 minus 0 and then minus this integral from 0 to 1 x to the power n plus 1 upon x plus 1 into dx. So it'll be log 2 minus this limit n tends to infinite from 0 to 1 x to the power n plus 1 upon x plus 1 into dx. Now when n tends to infinite, this x, it lies between 0 and 1. So this value will be nearly 0. So value of this integral is nothing but 0. So answer to this limit will be log 2, and that's your option number B. Now question number 79 is gxy is maximum of 12 minus x and 8 minus y. Then minimum value of gxy when xy varies over the line x plus y equals 10 is. Now we know that y is 10 minus x. So we can write this gxy as maximum of 12 minus x and 8 minus y. 8 minus y will be x minus 2. Now we'll consider this first case when 12 minus x is greater than x minus 2. That is when the value of x is less than 7. So in that case, 12 minus x is greater than x minus 2. So gxy will be 12 minus x. Now we need to find minimum value of g. Now value of g will be minimum. This x is maximum. So the maximum value of x in this case is 7. So it will be simply 12 minus 7, and which is 5. Now we'll take the second case when x minus 2 is greater than 12 minus x, that is when the value of x is greater than 7. Now if the value of x is greater than 7, then gxy will be x minus 2. Now this value will be minimum when x is minimum. The minimum value of x here is 7. So again g minimum will be 7 minus 2, which is 5. So the minimum value of gxy over the line x plus y equals 10 is 5, and that's your option number A. Now question number 80 is if alpha beta are less than 1 and greater than 0, then this summation k varies from 1 to infinite. This integral 1 upon k plus beta to 1 upon k plus alpha 1 upon 1 plus x dx is. Now first we'll solve this integral. So we know that integral of 1 upon 1 plus x will be log 1 plus x when the value of x varies from 1 upon k plus beta to 1 upon k plus alpha. So we can write this as log 1 plus 1 upon k plus alpha minus log 1 plus 1 upon k plus beta. So it will be simply log k plus 1 plus alpha upon k plus alpha minus log k plus 1 plus beta upon k plus beta. We can write this as log k plus 1 plus alpha upon k plus alpha and then into k plus beta upon k plus 1 plus beta. Now we need to take the summation from k equals 1 to infinite. So let it be tk. Now we'll put k as 1. We'll get this as log 2 plus alpha upon 1 plus alpha into 1 plus beta upon 2 plus beta. Now in the same way we'll put k as 2. We'll get log and then 3 plus alpha upon 2 plus alpha and then 2 plus beta upon 3 plus beta. Now this series will continue. Now we'll add them, then we'll get this summation k from 1 to infinite tk. It will be this log, and log m plus n is log m into log n. So we'll get this as 2 plus alpha upon 1 plus alpha 1 plus beta upon 2 plus beta into 3 plus alpha upon 2 plus alpha into 2 plus beta upon 3 plus beta. This series will continue. Now here we can cancel 2 plus alpha with 2 plus alpha and then 2 plus beta with 2 plus beta. In the same way every other term will cancel. So this summation, it will be log 1 plus beta upon 1 plus alpha, and that's your option number B. Now question number 81 is, if f is continuous from 0 to 1, we need to find this limit. Now we see j by n, we know that j by n, it corresponds to x, and 1 by n, it corresponds to dx. So we can change this limit into this integral, which is fx into dx. Now here x is j by n. Now we need to find limits of this function. When j is 0, clearly x is 0. So lower limit is 0. Now what about its upper limit? Its upper limit will be x equals greatest integer function of n by 2 upon n when this limit n tends to infinite. Now we know that greatest integer function of x is x minus fractional part of x. So it will be limit n tends to infinite n by 2 minus fractional part of n by 2 upon n. So it will be 1 by 2 minus this limit n tends to infinite fractional part of n by 2 upon n. Now fractional part, it always lies between 0 and 1. So anything finite upon infinite is 0. So the value of this limit is 0. So the upper limit of this function will be 1 by 2. So we can write this limit as this integral from 0 to 1 by 2 fx dx, and that's your option number D. Question number 82 is, we need to find volume of the solid generated by revolving about the horizontal line y equals to 2, the region bounded by y square is less than equal to 2x, when x is less than equal to 8 and y is greater than equal to 2. So we have this line y equals to, and then we have this parabola which is y square equals 2x. Now we are talking about region which lies inside of this parabola. Now we take this region from this point. So this point of intersection is when the value of y is 2, value of x is also 2. So this point is from 2 to x equals 8. So we take this region and then we rotate this region about y equals 2 line to form volume of revolution. Now we'll revolve it about this y equals to 2 line. Then we'll take any one element. We can write this small volume dv as pi. Now what is this radius? This radius is simply y minus 2. So it will be pi y minus 2 square and then its width, which is dx. So volume will be this integral from 2 to 8 and then pi, and it will be y square plus 4 minus 4y dx. Now y square is 2x. So we can write this as pi, and then from 2 to 8 it will be 2x plus 4 minus 4, and then value of y is root 2 x to the power 1 by 2 into dx. Now we'll integrate this function. We can write this volume as pi into, and here will be x square from 2 to 8 and then plus 4x from 2 to 8 and then minus 4 root 2, and it will be x to the power 3 by 2 upon 3 by 2 from 2 to 8. So here it will be pi, and then 64 minus 4, it will be 60 plus 4, and then 8 minus 2 is 6, minus 8 root 2 upon 3, and here it will be 8 to the power 3 by 2. 8 to the power 3 by 2 will be 8, and root 8 will be 8 into 2 root 2 minus 2 root 2. So we can write this as pi, and then 60 plus 24. So it will be 84 minus 8 root 2 upon 3, and here it will be 16. 16 minus 2 will be 14 root 2. So we can write this as pi 84 minus 16 into 14 upon 3. So it will be simply 28 pi upon 3, and that's your option number B. Now question number 83 is, if alpha and beta are the complex numbers, then maximum value of alpha beta bar plus alpha bar beta upon mod alpha into beta is. Now we'll say let alpha is r1 into e to the power iota theta 1 and beta be r2 into e to the power iota theta 2. Now alpha into beta bar, so it will be r1 e to the power iota theta 1 into r2 e to the power minus iota theta 2 because we have conjugate of beta, plus now alpha bar will be r1 e to the power minus iota theta 1 and then r2 e to the power iota theta 2 upon mod of alpha beta. It is nothing but r1 into r2. Now we can cancel r1 into r2. So we'll get e to the power iota theta 1 minus theta 2 plus e to the power iota and then minus theta 1 minus theta 2. Now this is cos theta plus iota sin theta and this is cos theta minus iota sin theta. So here iota sin theta will cancel. We'll get 2 cos theta 1 minus theta 2. Now we know that maximum value of cos is 1. So this expression is always less than or equal to 2. So maximum value of this expression is 2 and that's your option number A. Now question number 84 is for positive real numbers A1, A2 and A100, let P is summation of AI and Q is this product AI into AJ when I is less than J. Now we'll look at P. P is A1 plus A2 plus A100. Now we'll square it, we'll get P square and then it'll be A1 square plus A2 square plus A100 square and then plus 2 times this summation, which is when I is less than J is less than equal to 100 AI into AJ, which is nothing but Q. So from here we can say P square minus 2Q and it is equal to A1 square plus A2 square plus A100 square. Now we know that sum of any squares is always greater than 0. So from here we can say P square is greater than 2Q, that is value of Q is less than P square upon 2 and that's your option number C. Now question number 85 is differential equation of all the ellipse centered at origin is. Now we'll consider an ellipse whose centers at origin and axes are x-axis and y-axis. Then we can write this equation as x square upon a square plus y square upon b square equals 1. If we'll differentiate, we'll write 2x upon a square plus 2y y dash upon b square will be 0. Now we'll take this b square here. We can write b square upon a square x plus y y dash is 0. Now this is some constant, say lambda. So we can write lambda x plus y y dash is 0. Now we'll differentiate again. We'll get lambda plus y into y double dash plus y dash square equals to 0. Now we'll put the value of lambda. So we can write x into minus y y double dash minus y dash square plus y into y dash equals 0. So we can write this as x y into y double dash plus x y dash square minus y y dash equals 0, which is your option number B. But here I have a reservation. Problem here is ISI never said axes are parallel to x-axis and y-axis. When we have ellipse whose center is at origin, then it becomes central conic, and central conic is ax square plus 2hxy plus by square equals to 1. Now here we have 3 independent parameters. So order of this differential equation should be 3 and not 2. So answer to this question should be this option D, and that is none of these. So it is B only when center is at origin and axes are x-axis and y-axis. But in case of ellipse centered at origin, it will be a central conic, and in that case it will be a differential equation of order 3, and which is not given in any of the option A, B or C. So answer should be D, and that is none of these. Now question number 86 is the coordinates of a moving point P satisfies this differential equation. dx upon dt is 10x and dy upon dt is minus sine square x. If the curve passes through the point pi by 2 comma 0 when t is 0, then the equation of curve in rectangular coordinate is. Now we can write dy by dx as dy by dt upon dx by dt. So it will be minus sine square x upon 10x. Now this is nothing but minus sine x into cos x. So we'll write dy by dx as minus 1 by 2 into sine 2x. Now we can write this as dy and then minus 1 by 2 sine 2x dx. Now we'll integrate. We'll write y equals minus 1 by 4 and then minus cos 2x plus c. So this y will be 1 by 4 cos 2x plus c. Now we are given this initial condition that when x is pi by 2, y is 0. So we'll put y as 0 and x as pi by 2 will be cos pi. So it will be minus 1 by 4 plus c. So value of c is simply 1 by 4. So we can write this y as 1 by 4 cos 2x plus 1. Now we know that cos 2x is 2 cos square x minus 1. So this 1 and 1 will cancel. Then we can write y as cos square x by 2, and that's your option number A. Now question number 87 is, if xt is the solution of this differential equation and x0 is 1, we need to find the value of x1 by 2. We can write this differential equation as dx upon dt minus t upon 1 minus t square x 1 upon 1 minus t square, which is nothing but linear in x. Now first we'll find its integrating factor. Its integrating factor will be e to the power minus t upon 1 minus t square dt. We'll multiply by 2 and then we'll divide by 2. So this is e to the power 1 by 2 and then it'll be log 1 minus t square, which is nothing but under root of 1 minus t square. So we can write this result as x into integrating factor, which is 1 minus t square, and then this integral, which is under root 1 minus t square upon 1 minus t square, will be 1 upon under root then 1 minus t square dt, which is nothing but sine inverse t plus c. So we'll get x into under root of 1 minus t square as sine inverse t plus c. Now we are given this initial condition that when t is 0, x is 1. So when t is 0, x is 1. So this is 1, this is 0 plus c. So value of c is 1. So we can write this equation as x equals sine inverse t plus 1 upon under root of 1 minus t square. Now we need to find the value of x when the value of t is 1 by 2. So we'll put t as 1 by 2. We'll get this as sine inverse 1 by 2, and sine inverse 1 by 2 is pi by 6. So it'll be pi by 6 plus 1, and here it'll be 1 minus 1 by 4. So it'll be 2 upon root 3 and then pi by 6 plus 1, and that's your option number A. Now question number 88 again is a differential equation. We can write fx dy upon dx minus y f dash x, and it is equal to minus y square. We'll divide everything with minus y square fx. So it will be minus 1 upon y square dy by dx plus f dash x upon fx into 1 upon y, and this is 1 upon fx. Now what we'll do is we'll take 1 upon y as some v. So let 1 upon y equals v, then minus 1 upon y square dy by dx will be simply dv by dx. So we can write this as dv by dx plus f dash x into fx into v, and this is equal to 1 upon fx. Now this is linear in v. So first we'll find integrating factor. So its integrating factor will be e to the power integral of f dash x upon fx dx. Now we'll take fx as t, it will be dt. So it will be e to the power log fx. So its integrating factor is nothing but fx. So now we can write this result as v into fx, and it will be equal to fx into 1 by fx dx, which is simply x plus c. So we can write v as x plus c upon fx, where the value of v is 1 upon y. So it will be 1 upon y equals x plus c upon fx, or y is fx upon x plus c, and that's your option number C. Now question number 89 is, we are given this differential equation which is d2y upon dx square plus 2c dy by dx plus ky equals to 0. We can write this equation as m square plus 2cm plus k equals 0. Now for this quadratic equation, if we'll find d, it'll be 4c square minus 4k, so it'll be 4c square minus k. Now in the question it says c square is greater than k, so that means this is greater than 0. So this equation will have two real roots which are alpha and beta. Now we will find sum of roots is minus 2c and c is less than 0, so that means sum is greater than 0, and we'll find its product is k, and k is again greater than 0. So when sum is positive and product is positive, so alpha and beta, they are both greater than 0. So we can write this yx as a e to the power alpha x plus b into e to the power beta x, where both alpha and beta, they are greater than 0. Now if we look at mod yx, it will be mod of a e to the power alpha x plus b e to the power beta x. Now if limit x tends to infinite, now we know that alpha x will be positive, so it will be e to the power infinite. So when x tends to infinite, e to the power infinite, it tends to plus infinite. So answer to this question is mod yx tends to infinite as x tends to infinite, and that's your option number A. Now question number 90 is the differential equation of system of circles touching the y-axis at origin. So we have a circle which touches y-axis at origin. So this is origin, and let the center be at h comma 0. So we can write this equation as x minus h square plus y square equals h square. So it will be x square plus y square minus 2hx equals 0. Now if we'll differentiate, we'll get 2x plus 2y dy by dx, and it is equal to 2h. So what we'll do is we'll eliminate 2h. So we'll put the value of 2h here. So we'll get x square plus y square, and it'll be x into 2h, and 2h is 2x plus 2y dy by dx. So we'll get this as x square minus y square plus 2xy into dy by dx equals 0, and that's your option number D. Now question number 91 is, we are given this differential equation which is xy cube plus x square y to the power 7 dy by dx equals 1. Now we can write this as dx upon dy minus y cube x, and it is equal to x square y to the power 7. Now we'll divide everything with minus x square. So we'll write minus 1 by x square dx upon dy plus 1 by x y cube, and here will be minus y to the power 7. Now we let 1 upon x as v. So let 1 by x equals v. So it will be minus 1 upon x square dx upon dy, it will be dv upon dy. So we can write this differential equation as dv upon dy plus y cube v and minus y to the power 7. Now it is nothing but linear in v. So first we'll find its integrating factor. Integrating factor will be e to the power integration of y cube dy. So it will be e to the power y to the power 4 upon 4. So we can write this solution as v into e to the power y to the power 4 upon 4, and then this integral minus y to the power 7 into e to the power y to the power 4 upon 4 into dy. Now we'll need to solve this integral. So what we'll do is we'll let y to the power 4 upon 4 as z, then y cube dy will be dz. We can write this as v into e to the power y to the power 4 upon 4, and here it will be minus and then e to the power z into 4z dz. Now we'll solve this question using by parts. So this is first function and this is second function. So we can write v into e to the power y to the power 4 upon 4 and it'll be minus e to the power z 4z minus 4 plus c. Now we'll put z as y to the power 4 upon 4. So it'll be v into e to the power y to the power 4 upon 4 minus e to the power y to the power 4 upon 4 minus y to the power 4 minus 4 plus c. Now we'll also put the value of v, which is 1 by x. So we can write this as 1 by x e to the power y to the power 4 upon 4 minus e to the power y to the power 4 upon 4 into y to the power 4 minus 4 plus c. Now we are given this initial condition that when the value of x is 1 by 4, value of y is 1. So we'll put this value to find value of c. So we'll put x as 1 by 4. So it'll be 4 and then e to the power 1 by 4. And here will be e to the power 1 by 4. And if we'll put y as 1, we'll get this as minus 3 plus c. So value of c will be e to the power 1 by 4. Now we can write this differential equation as 1 by x e to the power y to the power 4 upon 4 minus e to the power y to the power 4 upon 4 y to the power 4 minus 4 plus e to the power 1 by 4. Now we need to find value of dy by dx when the value of y is minus 1. So first we need to find value of x. Now we'll put y as minus 1, we'll get 1 by x e to the power 1 by 4 will be minus e to the power 1 by 4 minus 3 plus e to the power 1 by 4. Now e to the power 1 by 4 will cancel. We'll get 1 upon x as 3 plus 1, which is 4. Value of x will be simply 1 by 4. So now we have this condition that when y is minus 1, value of x is 1 by 4. Now we need to find the value of dy by dx. So dy by dx is 1 upon xy cube plus x square y to the power 7. So it will be 1 upon, now y cube is minus 1 and y to the power minus 7 is also minus 1. So it will be minus and then x. Value of x is 1 by 4 and then x square is 1 by 16. So it will be minus 16 upon 5 and that's your option number D. Now we are given a group G which is AB0 A inverse, AB0 a to the power minus 1 and we are given this n which is 1B01. Now first we need to find if this n is a normal subgroup. So if we'll take any element m which is A, B, 0 and A inverse, we'll find m, n, m inverse. Now m is A, B, 0, A to the power minus 1, n is 1B, 0, 1 and then what is m inverse? M inverse is simply 1 and then we'll interchange A and D. So it'll be A inverse and A and then minus B and 0. Now we'll multiply this first. So we'll write A0, B A inverse and here it'll be A inverse and here it'll be minus B plus AB. This one is 0 and here it will be A. Now we'll multiply these two. So we'll multiply them. Then we'll write 1 and then minus AB plus A square B plus AB and here again it'll be 0 and then here again it'll be 1. So we'll get this as 1 A square B 0 and 1 which is of the form 1B 0 and 1. That means it belongs to n. So n is a normal subgroup. Now what about this quotient group G by n? Now we consider this map which is G to R positive cross R positive which is given by AB0 A inverse to A comma 1. Then it is easy to check that this G is a homomorphism. Now kernel for G is N. And hence by first isomorphic theorem, we can say that this G by N is isomorphic to R positive cross R positive, and that's your option number D. Now 93 is, let G be a group with identity element E, and if X and Y are elements in G satisfying X to the power 5, Y cube is equal to X to the power 8, Y to the power 5 equals E, then which of the following condition is true? Now what we'll do is, in this, we'll multiply X to the power minus 5 on the left and Y to the power minus 3 on the right. We'll write X to the power minus 5 into X to the power 5, and Y to the power 3, Y to the power minus 3 will be X to the power minus 5 into X to the power 8, Y to the power 5 into Y to the power minus 3. Now this is E, and here it will be X cube into Y square. Now we can write X cube into Y square is equal to X to the power 5 Y cube. So X cube Y square will be X to the power 5 into Y cube. Now we'll multiply X to the power minus 3 on the left and Y to the power minus 2 on the right. Now this is E, and here we'll get X square into Y. Now again X square Y will be equal to X cube Y square. So we can write X square Y, and it is equal to X cube into Y square. Now we'll multiply X to the power minus 2 and Y to the power minus 1. So here it will be E, and here it will be X into Y. So from here we can say XY is equal to E. Now if XY is equal to E, we can write XY equals X square Y. Now we'll multiply with X inverse. So X inverse into X, Y into Y inverse, X inverse into X square, Y into Y inverse. Now this is E and this is X. So from here we can say value of X is E. In the same way we can prove that value of Y is E, and that's your option number A. Now question number 94 is, let G be this group plus minus 1 and plus minus iota with multiplication of complex numbers as composition. Now H is this quotient group Z by 4Z, then number of non-trivial group homomorphism from H to G is. Now this group G, it is a cyclic group and order of G is 4. Now this quotient group Z by 4Z, it is isomorphic to Z4. So therefore this Z upon 4Z, it is also a cyclic group of order 4. So if we have to find number of homomorphism, it is given by GCD of, now order of this group is 4 and order of this group is also 4. So 4 comma 4 will be 4. Now out of these 4, there is one trivial homomorphism. So we'll remove that. Then we'll get number of non-trivial group homomorphism as 3, and that's your option number D.